This is a Fluke calibrator, or process calibrator as they're often called. Basically it's like it's a multi-function device really. It's similar to my Rowan calibrator, but this is actually a meter as well. It's sort of quite useful for using as a normal voltmeter. This is obviously much more modern than the Rowan, and I picked this up on eBay, badly listed for not a lot of money actually, and it came with the original Fluke case and a couple of spare batteries. No charger, unfortunately. That's a bit of a problem because they use cadmium cells, you know, like a laptop battery sort of thing. It's not like a battery you can just change and put the back on again. It's like a replaceable cell. I'll show you that in a moment. So I've charged the batteries up at work this evening, or this afternoon, when it arrived, just after it arrived, and I've powered it up. It appears to be working perfectly fine, apart from obviously I can't charge the batteries easily, so the next thing will be to look out for a battery charger. So just to quickly run through what I understand of it so far. It's got the ability to sort of log results, so it's sort of like an inbuilt data logger, but it's a voltmeter and ammeter. It's a bit limited on what it will do as a DVM or a multimeter. It's sort of limited to sort of a fairly low voltage, I think about 250 volts maximum. I'm not sure, I need to check on that, on what it will measure, but it will source voltage and current. I think a voltage up to about 11 volts and current up to about 20 milliamps. It'll also source a resistance, which is nice for calibrating meters and things like that. It's also got its thermocouple input here that's useful for different types of thermocouple, like K-junction, K-type thermocouples and all the other types, J-type, K-type. It's got an option, as you see here, this switch here, which is a pressure sensor. That's an extra module that goes on the back, so you can use it as a thermometer. I think that's the right word. And then it's just got various other things it can do. It will generate frequency. I don't think it will generate AC voltage. When it's generating the frequency, it's actually generating a square wave, so it's not a pure sine wave generator inside it. And it will do different types of thermocouples as well. It will also do the sort of like the PT100, which are quite common in sort of industrial machinery. So basically the bottom section down here is split into two sections. If you see here, this is the source section where I'm connected with my Pomona leads at the moment. So basically, these two sections here are output leads basically. So this is supplying voltage and feeding in, I don't know if you can see here, it says RTC, which is basically thermocouple simulator, or a probe simulator, so you can actually feed in a given resistance into a thermometer and it should give you the right temperature range. I think a PT100 I think is 0.1 ohm or 100 milliohms is equivalent to 0 degrees Celsius or something like that. So the idea is so you can check the functionality and calibration of your digital thermometer. The thermocouple input, when you generate a signal, because these type of thermocouples like the K-type work on dissimilar metals, so any voltage potential you get between the two is simulated here and fed into your thermometer, and therefore you can check your thermometer for accuracy. So that's in its source mode. We've also got a milliamp. This is our milliamps where our current's put out, and if we want to measure our voltage, feed a voltage out and do our resistance, as I say, we use the left-hand terminals. So the left-hand side is resistance and voltage, and the right-hand side is for current. If we're actually using it as like a conventional multimeter, we feed all our signals into the voltage signals into the right hand side, so our voltage goes in here, and you see it says 300 volts maximum, and you see these warning symbols to stop you putting voltage back into the unit, which would obviously cause a bit of damage. You wouldn't want to do that, so you have to be a bit careful when you use this. And our current measuring and resistance measuring and thermocouple measuring. So if we're actually measuring the thermocouple that we from our thermometer, our PT100 for example, we use these 4 wires here, the 4 wire sense sort of section, and that's likewise milliamps and volts are registered here. So let's just power it up quickly and just show you roughly what it does. You can be able to see this display. He says powering it up. Come on. No, I don't think I've got very good battery connections. I need to have a quick look at those, but you see it's powered up. I'm trying to adjust it. It has got adjustable contrast, so just adjust it so you can see it a bit clearer. Hopefully you can see the display there. It's getting the angle right where you can actually see it. Okay, so at the moment we're in the voltmeter mode, and it's basically all it's doing is it's acting as a DVM, and that's fine. It's in its measure mode, and you can see at the top here it says measure. If you want to measure AC volts, there's your AC volts. Press it again, you can select the frequency and what sort of range you want. Ohms, and then thermocouples. Then you just select the thermocouple. You can see this. It's very difficult to tell if you can see this or not. The display isn't actually that clear because it's an LCD display, and particularly because I'm working at an angle. I find it it's probably the best you're going to get it. So you can select your thermocouple type here, and then if I press the Voltmeter mode, it's attempting connection, as you see, and it obviously can't connect to anything because it simply hasn't got a mamometer connected. So we'll go back to volts now. So what I'm going to do is my recently calibrated Solartron. We'll just run a couple of voltage measurements on that just to see what it comes up with. So if I press let's zoom out again so you can see volts. Okay, then I press measure and source. So at the moment it's in the measure mode. I press that and it says select selection off. So I press volts. It's right in a minute. Then enter 5 volts. So at the moment now the unit is sourcing 5 volts, and turn around and have a look at the Solartron, and the Solartron agrees that it's 5.0001 volts, so that seems to be working fine there. Let's try the lower voltage range, so let's try 100, and I can select millivolts here. Obviously I can put 0.1 of a volt, that's the same. 100 millivolts, enter, and it's sourcing 100 millivolts. The Solartron clearly shows 100 millivolts, which is reassuring because obviously the meter's well calibrated. That seems to be working pretty well. To select current mode, obviously I need to change the leads, and last time I tried it's a bit of a fiddle, but first of all I'm just swapping the leads at the moment over on the Solartron and selecting the current reading, and then all I do is I press milliamps, and I want source milliamps. This is for simulating transmitters, so that's things like thermocouple and things we're not interested in at the moment. Press enter, and then it will ask you for what milliamps you want. I'm swapping my leads over. I'll swap my leads over, as you can see what I'm doing. Swapping my leads over to the milliamp, because this is where the milliamps is sourced. And we'll start with, say, 10 milliamps. 10, enter. And the Solartron hasn't got a particularly high resolution on the amps range, but you can see it's within the ballpark, 9.98, 10, something like that. That's pretty good. Quite pleased with that. We could try a higher current. Let's try 20 milliamps. I think it will go to about 22, 23. There's 20 milliamps. Pretty good. So it's clearly working really nicely. It's in really good condition. Let me just show you the sort of batteries. Let me just move this out of the way so you can see what batteries it came with. It's these type of batteries, and these are cadmium NiCad batteries, so it's obviously pretty old. These batteries have been sort of lying around there. It's totally flat. I charged them up with just an external current regulated power supply. and they seem to recovered. Okay. It probably hasn't had an awful lot of use, and something like this wouldn't have actually. So I'm after a couple of maybe a charger for this, which is going to be probably fairly difficult to track down because Fluke stuff is bloody expensive. And I had a look on eBay, and there were a couple of them available. On the side of the unit, let me just show you what we've got inside here. So we've got a serial port here, and that basically so you can send information to the computer, obviously before USB. It's still got a calibration seals intact, which is nice. This is our port for the pressure meter, and this is an external supply. Now it looks to me, when I've done a bit of searching online to try and work out what supply it needs, it looks like it's a 7.5 volt supply, but the other thing to note is this is center negative on here, not center positive. The Fluke for some reason used center negative a lot, and I know a lot of the Sony radios did it back in the 80s. They were center negative for some reason. So this is center negative supply, and that allows me to run it obviously without the battery connected. And that's the battery holder in the back, and that's the other battery that's in there at the moment. Normally there's a little plastic clip that I'll show you in a minute that holds this battery in. It's got a tilting bail at the back, and it's sort of like a real ruggedized case. Nice meter and nice build quality Fluke. Let me just show you the spin you round a bit and show you the case. Came with a lovely sort of zip up case. This is the center section where the obviously where the meter lives. We've got two sections at the side with little zip up things. And inside here we came with a couple of nice sort of strange clips. I've never come across clips like that. They're nice, aren't they? Sort of like alligator clips in an insulated shield, like those. So it came with a set of those. That's the little clip that holds the battery in. I've just left that out at the moment because obviously the batteries are being swapped left and right as I mess about the unit to try and get it to charge. The other section here has got a that's something else. That's a relay for my Ballantine calibrator. That's relay is packed up. Some more clips on the other side, and obviously storage for batteries and things like that. And on the back, it's got the a little zip case where the service manual is. So yeah, it's a lovely bit of kit. As I say that with everything, don't I? But it's a typical Fluke build quality. It's in really great nick. I got it for a ridiculously cheap price considering some of the prices that they're going on eBay for. I'm very pleased. Okay, well, that really sums that up really. Hopefully you'll see this in use a bit. I don't know if it'll be a replacement for the Rowan or not. I'm not too sure, but at the moment it's probably more functionable than had more functionality than the Rowan, because obviously it's a bit easier to use. It's got a digital display, whereas the Rowan's a bit clunky and a bit sort of 1980s sort of style. The Rowan seems to be very accurate, but the battery is dying on it. I need to get a new battery. But yeah, that's the Fluke 702 documenting process calibrator. Thank you very much.